Welcome. What we're going to do here over the next few minutes is show you how to graph the old-fashioned way. What we have here is a piece of graph paper set up. We'll end up drawing a vertical, a y-axis, as well as a horizontal and x-axis, labeling them appropriately, putting a main title on our graph. When we label our axis, we will include a title for that axis, as well as the units for that axis on both the y and the x, or in both the y and the x direction. Further, we'll plot our data. In this case, it will be density data in the form of mass and volume. The mass will end up being on the y-axis. The volume will end up being on the x-axis. So we'll plot our dots, and then we will add a trend line. That trend line will allow us to get more out of it than just a visual representation. So let's get started. Okay, first, we are going to draw in our axes. I would do this with a ruler, so it's nice and straight. We have both our horizontal and our vertical axes drawn here. They are also labeled appropriately. So we have a unit scale here, mass, in units of grams, and volume in units of milliliters. You can also see that I've already added the density of water as my main title. The next bit of data that I want to include on my graph is a scale. Right? Here, what I did is I counted the total number of hash marks. There were 26 here, so I just cut it off at 25 and then put a hash mark on every fifth line. Okay, so 1, 2, 3, 4, 5. That represents 1, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, 2.6, 2.8, 3, so on and so forth. So a little side note is that every mark is 0.2 milliliters. And here we have actually the same exact scale, 0, 0.2, 0.4, 0.6, 0.8, 1, so on and so forth. So here as well, every mark is equal to 0.2, but in this case instead of milliliters, it's 0.2 grams. Now I wouldn't write this on a final graph that I would hand in, however it's useful for now, just for reference. So we've set up our scale, looks good. Moving forward, we're going to plot our dots. In this case, our data points are here. The mass was 4.6, 4.1, 3.2, 1.9, 0.9, 1, 2, 3, 4, 5. Actually doesn't matter which order this data is in, since we're just plotting dots, the order of operation doesn't really matter. We can plot this set first. This set, it doesn't really matter because you're going to go up 4.1 and over 4. Plot a dot. Up 1.9, over 2. Plot a dot. Go back to where we were. So I plotted the dots here. Up 0.9 over 1. Up 1.9 over 2. Up 3.2 over 3. 4.6 over 5. And then up 4.1 over 4. Okay. So those are the data points. After we plot our data points, the next step is going to be adding a trend line. A trend line is going to not really intersect any point. It's just going to, you draw it with your ruler. It'll be a nice straight line, and it'll kind of be like an average line. Some of the dots will end up being below our trend line, and some of the dots will be above our trend line. Okay, so I did my best. I drew a line here, and I wrote the equation, or the general form of an equation when we have a straight line. Y equals mx plus b. Okay, that is the general form. We want to know what ought to go here, what ought to be the m, and what ought to be the b. All right. How do we figure those two things out? Well, m stands for the slope of the line, and B stands for the y-intercept. So let's take a look at those two pieces. For B, okay, B is the y-intercept. All we need to do is look at where does it cross the y-axis. Here's where it crosses the y-axis. This is at the 0.2 mark, so this is actually plus 0.2. Alright. The slope is a little bit more tricky. Slope is rise over run. In this case, the rise, we ought to be paying attention to mass, and the run will be with respect to the volume. So we got to find 2 points that intersect on this line with our grid. We just go ahead and look at this point here right up front, and then coming up this line. These don't really match up with anything in particular, and this point looks like it matches up. Okay, now how much did the graph rise and run? When we analyze this, I drew a dotted line up and a dotted line across. It went up. Remember our scale, 0.2 grams is what each increment represents. 0.2, 0.4, 0.6, 0.8, 1. 1.2, 1.4, 1.6, 1.8, 2, 2.2. So that's how I got the rise of 2.2. Remember, rise over run is slope. And the rise in this case is 2.2 over the run. Every mark represents 0.2 milliliters. 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2, 2.2, 2.4, 2.4. And of course our units are milliliters for run and grams for rise. So it'd be grams per milliliter. Alright. And hey, guess what? I remember from some of the calculations we've done in the past, the units for density are in grams per milliliter. The significance of doing this calculation is it provides us with the slope of the line, which also represents the actual density of water. Right? Perform this calculation in your calculator and you should end up with 0.99, and the slope of our line 0.99, y equals 0.99x plus 0.2. That's pretty significant. Chances are you haven't calculated the equation of a line before. It's not that difficult. It takes a little bit of time, but it strengthens our graph a whole lot, and it tells us a lot of new information. All right, this equation is the bread and butter of graphing. This tells us what the density of our material is, because it tells us the slope of our line, and it'll end up allowing us to predict other measurements that maybe we didn't take. Okay, if we wanted to figure out, if I had some water and it had a mass of 4.6 grams, what would be the volume that it would take up? Well, just go over, hit the line, and drop it down. It should be about 4.6 milliliters. On the other hand, if I were to say, alright, what if I have 1.2, 1.4, 1.6 milliliters of water? How much mass is that going to be made up of? Just bring that guy over, and you're looking at about 1.2, 1.4, 1.6, about 1.7. Alright, so the trend line is going to allow us to predict events that we did not measure. Right? And this is really the main importance of graphing. Okay? Hopefully that makes sense. If you have any more questions, feel free to comment or ask. Thanks a lot.